Hello everyone, I am Rovelyn A. Almonicar, and now we are going to learn the measures of correlation. Correlation is a statistical tool to measure the association of two or more quantitative variables. It is also defined as the measure of linear relationship between two random variables x and y, and is denoted by a symbol r. That is, R measures the extent to which the points cluster about a straight line. There are three degrees of relationship or correlation between two variables. First, the perfect correlation, positive and negative. The second one is some degree of correlation or positive and negative. The last one is no correlation. The quantitative interpretation of the degree of linear relationship existing is shown in the following range of values. Positive or negative 1 is the perfect positive or negative correlation. The positive or negative 0.91 to 0.99 is the very high positive or negative correlation. The positive or negative 0.71 to positive or negative 0.90 is the high positive or negative correlation. The positive or negative 0.51 to positive or negative 0.70 is the moderately positive or negative correlation. The positive or negative 0.31 to positive or negative 0.50, the low positive or negative correlation. The positive or negative 0.01 to positive and negative 0.30 is the negligible positive or negative correlation. The last one is 0.00 or 0 is no correlation. Next is the scatter point diagram. A scatter point diagram is used to illustrate the relationship between two variables. The following illustrations show the scatter point diagram for different types of correlation. The Pearson product moment correlation coefficient. The various correlation coefficient being currently used, the most widely used computational formula for correlation is the Pearson product moment correlation coefficient, the symbol of which is R. The size of the correlation varies from positive 1, small 0 to negative 1. The formula for the Pearson R is R equals to summation of xy minus summation of x multiplied by summation of y all over square root of summation of x squared minus summation of x plus an open parenthesis squared multiply then bracket and summation of y squared minus summation of y plus an open parenthesis squared, then bracket. Where x the observed data for the independent variable, then y the observed data for the dependent variable. The n is represent sample size. Then the r is the degree of relationship between x and y. Here is the table for our example. Suppose we want to find out if a relationship exists between the height and weight of 20 UE college students. In the first column is the student, then the second column, the x, then the value of y, then the fourth column is our xy. To get the answer for our xy, you can multiply the value of x and y. Example for our first row.
170 times 72 equals to 12,240. So that is our xy. Then in the fifth column will be the x squared. The value of x, you can square that. The 170 squared equals to 28,900. Then the last column, the y squared. The value of y, you can square that. The 72 squared equals to 5,184. Before we substitute in our formula, to get the answer first, you have to find the summation of all the column. You can total the numbers and summation of x, summation of y, our summation of xy, in our summation of x squared, and the summation of y squared. Since we have a value for our summation of x, summation of y, summation of xy, and summation of x squared, and summation of y squared, in our formula, r equals to n summation of xy minus summation of x times summation of y over square root of n summation of x squared minus summation of x close and open parenthesis squared times n summation of y squared minus summation of y close and open parenthesis squared. Then we substitute the value for its represents. R equals to, our n is 20 times the value of summation of xy, which is 280,925. Copy the minus. Then the value of summation of x is 3,539 times the value of summation of y, 1,578 over square root. Our n is 20 times the value of summation of x squared, which is 628,435. Copy minus. Then the value of summation of x, 3,539, then squared, times the value of n, which is 20, then the value of summation of y squared, which is 126,012, then minus the value of summation of y is 1,578, then squared. Next, r equals to 20 times 280,925 is equals to 5,618,500. Then copy minus. Then multiply the value of summation of x and summation of y, which is 3,539 times 1,578 equals to 5,584,542 over the square root of, then multiply the 20 times 628,435 equals to 12,568,700. Then copy minus. The square root of 3,539 is equals to 12,524,521. Then times 20 times 126,012 is equals to 2,520,240. Then copy minus. Then the square root of 1,578 is equals to 2,490,084. Then R equals to 5,618,500 minus 5,584,542 is equals to 33,958 over, then copy the square, 12,568,700 minus 12,524,521 is equals to 44,179. Then 2,520,240 minus 2,490,084 is equals to 30,156. Then R equals to, copy the numerator, which is 33,958 over square root of, you can multiply the denominator, 44,179 times 30,156 is equals to 1,332,261,924. Then R equals to, copy the numerator, 33,958 over square root of 36,500.16. Then R equals to 33,558 divide square root of 36,500.16. R equals 0.93. Our R is equals to 0.93. By using the formula of Pearson's R. Referring to our table of qualitative interpretation of R, we can conclude that the heights of weights of the 20 students in the sample are having a very high positive condition. The scatter point diagram of the example above is shown below. The diagram shows a very high positive linear correlation. This means that as the height increases, the weight also increases, and vice versa. Next, the other interpretation of Pearson's R. Coefficient of determination. The coefficient of determination R squared measures how well a statistical model predicts an outcome. The outcome is represented by the model's dependent variable. As noted above, correlation coefficients are interpreted in a relative sort of way by thinking about high, moderate, or low coefficients. However, the best way of evaluate an R is by the use of the coefficient of determining, denoted by R squared. In our example, our computed R is equals to 0.93. The coefficient of determination R is equals to 0.86 because the square root of 0.93 is equals to 0.86 something. So always remember, you can get the 2-digit after the decimal point. So our coefficient determination is equals to 0.86. This means that for the 20 college students in the sample, 86% of the variation in weights could be attributed to the variation in heights. The rest, 14%, is chance variation. Then always remember, the coefficient of determination is always positive, even when the correlation is negative. Then, the testing the significance R. The test for significance of R is needed in order to know whether the computed R is significant or not. Let us consider our example where the computed R is equals to 0.93. Let us determine whether the computed value is statistically significant. First, our null hypothesis of population is equals to 0. There is no significant relationship between heights and weights of the 20 college students. Then, the alternate hypothesis of population is equal to 0. There is a significant relationship between heights and weights of the 20 college students. Next, the level of significance. By finding the testing the significance of R. Using the p-value method, you could choose any appropriate significance level you want. You are not limited to using alternate hypothesis is equals to 0.05. But the table of critical values provided in these textbooks assumes that we are using a significance level of 5% is equals to 0.05. Our alternate hypothesis is equals to 0.05 or 0.05. Then our DF, the formula for our DF or degree of freedom is equals to n minus 2. Then our n is equals to 20. Then minus 2. Our DF is equals to 20 minus 2 is equals to 18. Next, our test is statistic. Our formula is T equals R square root of n minus 2 over 1 minus R squared. The decision rule is to reject null hypothesis if T computed is greater than 2.10 or lesser than negative 2.10, otherwise accept alternate hypothesis. In our computation, by using the formula of T equals R square root of n minus 2 over 1 minus R squared, we need to substitute. Our R is equals to 0.93. Then square root. Our n is equals to 20 minus 2 over, copy the 1, then minus, then the value of R equals to 0.93, then squared. Next, T equals to 0.93 square root of 20 minus 2 is equals to 18 over, copy 1, then minus, the square root of 0.93 is equals to 0.8649. Then T equals to 0.93, then square root copy the numerator, which is 18 over 1 minus 0.8649 is equals to 0.1351. Then t equals to 0.93 is square root of 133.23. T equals to 0.93. The square root of 133.23 is 11.5. Then t is equals to 0.93 times 11.5 is equals to 10.73. Our t is equals to 10.73. Next, our conclusion. Since 10.73 is greater than 2.10, reject null hypothesis and accept alternate hypothesis. Therefore, we can say that there is a significant relationship between weight and height of the 20 college students. Let's proceed an alternate formula for R. The formula, which is R equals to summation of xy, then summation of x times summation of y over n, then all over square root summation of x squared minus summation of x close and open parenthesis squared over n times summation of y squared minus summation of y, then close and open parenthesis squared over n, or R is equals to summation of xy minus summation of x times summation of y over n, then over summation of x squared minus summation of x close and open parenthesis squared over n times summation of y squared minus close and open parenthesis summation of y then squared over n. R is equals to the value of summation of xy is 280,925 minus the value of summation of x 3,539 times the value of summation of y 1,578 over the value of n, which is 20. Then all over square root the value of summation of x squared, which is 628,435, then minus the value of summation of x, which is 3,539, then squared over the value of n, which is 20, then multiply the summation of y squared, which is 126,012, minus the value of summation of y 1,578, then squared over n, which is 20. R equals to 1,697.90 over square root 2,208.95 times 1,507.8. Then R equals to 1,697.90 over 2,208.95 times 1,507.8 is equals to 1,825.008167. R is equals to 1,697.90 divide 1,825.008167 is equals to R equals 0.93. As you can see, the person's formula and alternate formula, which is coincide the answer. Thank you for your listening and watching my topic about measures of correlation. I hope you understand my discussion. Thank you and may God bless us all. This is your future educator, Sister Rubelin A. Almonicor. May God bless.